Among the many hazards that occur on construction sites, collapse and burial accidents are types of incidents that can lead to massive damage in a very short span of time. During the process where various structures, such as ground, shoring, scaffolding, or formwork, suddenly give way, workers often become trapped by earth or construction materials. And if rescue operations are significantly delayed, their very lives are then gravely threatened. Due to these characteristics, collapse and burial accidents have a high mortality rate and severe after effects, so they are classified as areas that must be proactively managed on site. The learning content of this lecture is the prevention of collapse and burial accidents at construction sites. We will practically approach how accidents start from certain factors, what structural and operational risks are repeated, and how to control them on site. The learning objectives of this lecture are as follows. First, it is to clearly understand the causes and main types of collapse and burial accidents. Secondly, it is about reaching a level where you can explain the necessary safety management procedures and emergency response plans to prevent accidents. Through this lecture, you will be able to understand collapse and burial accidents as complex disasters caused by the interaction of ground and structural work methods, rather than just simple structural damage. Collapse and burial accidents occurring at construction sites are complex disasters, typically resulting from various risk factors acting simultaneously. First, let's examine collapse. It refers to the phenomenon where structures such as buildings, retaining walls, scaffolding, or even the ground itself are unable to withstand their own weight or maintain their structural integrity due to external forces, ultimately leading to their complete collapse. Here, external forces refer to not only natural factors like heavy rain or earthquakes, but also vehicle vibrations, heavy equipment loads such as excavators or cranes, and excavation work at adjacent sites. Poor construction is a major cause, as structures can easily collapse if they lack strength, or if connections and supports are improperly installed during the building process. Such collapses don't only occur during construction, they can also happen long after completion due to ground shifts or additional loads. Entrapment refers to a situation where workers or equipment are covered by soil or structures due to a collapse. Typical examples include workers being buried under a pile of soil as the ground collapses, or workers on a lower floor being crushed by structures as scaffolding collapses. Especially during excavation, tunnel construction, or underground structural work, if the earth-retaining structure weakens even slightly, soil can instantly pour out, leading to a high risk of accidents. The causes of such accidents are relatively clear. If excavation proceeds when the ground is weak, or if there are buried objects within the ground preventing sufficient support, the risk of collapse significantly increases. When groundwater seeps in due to improper drainage, or when soil moisture increases during heavy rain, the ground becomes heavy and loses its supporting strength. Another major cause is when retaining walls, shoring, or supports do not meet design standards or are poorly installed. Improper excavation, like digging wider than planned or undermining, destabilizes the ground, easily leading to collapse. If management procedures such as risk assessment, TBMS, or site inspections are missed, the likelihood of an accident increases further. Construction sites are structurally fast-changing and unpredictable environments. Especially in confined spaces or deep excavation sections, changes in the ground must be meticulously tracked, and instability significantly increases when external factors, such as the load of adjacent structures or groundwater flow, act simultaneously. There are many cases where manpower and equipment are simultaneously deployed here, increasing the risk of initial collapse leading to secondary accidents. According to statistics from the Ministry of Employment and Labor, collapses and burials account for about 20% of fatal accidents in the construction industry, indicating a significant proportion. Many cases have seen the Serious Accidents Punishment Act applied. When these accidents occur, both fatality rates and injury severity are high, making this a disaster type that must be prioritized and managed on-site. Collapse and burial accidents usually happen when the ground or temporary support structures cannot withstand the forces they are meant to bear. If the ground is weak or groundwater flows in, the soil may not be able to maintain its shape on its own and can collapse rapidly. Additionally, if the retaining wall or support structures are not installed according to design standards or are not properly inspected after installation, the excavation phase can easily collapse. During periods when soil moisture rapidly increases, such as heavy rainfall or thawing seasons, the ground suddenly weakens, increasing the risk of accidents, And at sites where basic safety management, such as risk assessment or toolbox meetings, is not implemented, even small signs can lead to collapse due to inadequate response. The load of adjacent structures, repeated loads from heavy equipment like excavators or cranes, and external forces such as earthquakes or vibrations can push earth pressure past its limit, causing structures to collapse. When such collapse and burial accidents occur, the physical harm suffered by workers is extremely fatal. In a situation where the whole body is pressed by earth and sand, a pressure close to 1.5 tons instantly compresses the chest and abdomen, causing the organs to be crushed and ribs to break in succession, making it difficult to breathe immediately as the lungs cannot expand. Often, the internal organs are pushed or squeezed to one side, leading to loss of consciousness and collapsing on the spot. Arms or legs are often hit by soil and concrete fragments, bending abnormally, and frequently suffer comminuted fractures where bones shatter. In these situations, muscles, blood vessels, and nerves are simultaneously severed, leading to immediate bleeding. If emergency response is delayed, it becomes a life-threatening condition. Compression asphyxia, where the chest is compressed and the lungs cannot function, is also a very common injury. Within seconds, one may experience shortness of breath and chest pain, and if breathing stops, the heart can immediately cease to function. Even if only the lower body is buried, severe issues can arise. If compression is prolonged, blood flow is blocked, and toxic substances rapidly accumulate in the tissues. After rescue, when the compression is released, these substances enter the bloodstream all at once, causing acute kidney failure. Even if they appear conscious, it's a very dangerous state where organ damage has already progressed. When falling objects and soil pressure act together, the head and neck suffer fatal damage. Skull fractures or brain hemorrhages occur instantly, and if the cervical spine is damaged, the nervous system is instantly paralyzed. Breathing becomes impossible. Within confined or buried spaces, physiological changes manifest with alarming speed. As oxygen levels become critically low, individuals may experience severe headaches, confusion, and even seizures. Furthermore, inhaling soil and debris can obstruct the respiratory passages, potentially leading to additional and fatal asphyxiation. The body's core temperature also plummets rapidly, very often resulting in life-threatening hypothermic shock. The longer the rescue is delayed, the lower the chances of survival. If rescued within 5 minutes of being buried, the chances of survival are high. But after 15 minutes, severe hypoxia begins. And after 30 minutes, the mortality rate increases sharply. Because surviving for over an hour is very rare, in collapse and burial accidents, the speed of initial response is paramount. This time, we will continue to look at actual collapse and burial accident cases that occurred at construction sites. This is because only by specifically understanding what situations are repeated on site can preventive measures be accurately applied. The first case is a soil collapse accident that occurred during excavation work. In the middle of a city, while excavating to a depth of about 4 meters, the sidewall soil collapsed, quickly burying 2 workers. Excavation at this site proceeded without conducting a ground survey, and necessary earth retention or support structures were not installed for excavations exceeding 2 meters. Drainage facilities were not adequately set up, so after heavy rains, the ground was saturated and the safe slope of the excavation surface was insufficient. Risk assessment and drilling investigations were omitted before excavation, and with no on-site supervision, immediate action was impossible. This accident could have been entirely prevented if the ground conditions had been surveyed and support structure plans and drainage measures prepared before excavation. If there are just procedures like stopping work when there is a rain forecast and covering the excavation phase with a waterproof sheet and sharing the risks through TBM the day before the work starts, the possibility of an accident is greatly reduced. Next, the second case is a collapse in an underpass after heavy rains. Immediately after the monsoon, a retaining wall in the underpass tunnel section overturned, and the earth support collapsed, damaging nearby structures and bearing equipment. At the time of the accident, the drain was blocked, so rainwater kept entering behind the earth retention wall. Soil pressure rapidly increased, and the structure couldn't withstand it. Despite this, drainage inspections were not carried out, and necessary safety procedures during construction were repeatedly omitted. Drainage facility management was inadequate, and emergency measures for weather forecasts were not prepared. There was no procedure to check ground stability after rainfall. For prevention, it's essential to inspect drains and sumps before and after heavy rainfall and remove debris. Additionally, measures are needed to install drainage layers and perforated pipes behind retaining walls to disperse water flow. After rainfall, ground stability must be re-evaluated and the need for further reinforcement assessed. Also, we must operate a system that checks weather information in real time and can immediately stop work if danger is detected. These two examples clearly show the key areas where collapse and burial accidents repeatedly occur, such as excavation, drainage management, and earth retention structures. This can be seen as a prime example that demonstrates the consequences when safety management procedures are omitted or inspections are inadequate. To prevent collapse and burial accidents, it is most important for supervisors and workers to accurately understand and perform their respective roles. First, we'll take a look at the responsibilities of the supervisor. The supervisor must check and record the safety checklist every day before starting work and ensure that actual risk factors are properly reflected in the work plan. It's crucial to verify if reinforcement measures were properly implemented based on the risk assessment. Ground conditions, drainage, and temporary support installation must all be checked through visual inspection and measurement. Given that supervisors also possess the authority to halt or resume operations based on changing weather, an emergency inspection plan must be established beforehand when heavy rain or strong winds are predicted. You must personally oversee the installation, dismantling, or reinforcement of ground support, ensuring the construction sequence is followed. You also need to lead the TBM meeting and accurately share daily risks with workers. You must also check the workers' PPE use and if access control lines are maintained. If danger is detected, you are responsible for immediately stopping work and guiding on-site evacuation. Inspection results must be reported to managers and clients, and records must be kept. The role of workers is also very important. Prior to work, you must fully wear all personal protective equipment, including helmets, safety shoes, and belts. You must never enter areas other than designated entrances and safety passages. If there are signs of collapse, such as cracks, subsidence, soil flow, or tilting walls on site, it must be reported immediately. Access to areas without support structures or designated as danger zones should be prohibited. If you notice unusual sounds, vibrations, or moody water inflow during work, stop work immediately and report it. Strictly adhere to the work procedures and safety regulations shared by TBM. And on days with rain or strong winds, you must not proceed with work without a supervisor's instruction. In areas with moving equipment, you must stay behind exclusion zones and follow the signalman's instructions. Also, if you spot dangerous actions by colleagues, you must warn each other and immediately report them to management. A cooperative system is essential. The more diligently supervisors and workers perform their respective duties, the faster on-site risks diminish. Collapse and entrapment accidents have very brief warning signs and extremely limited response time. Therefore, consistent role fulfillment is crucial for accident prevention. When a collapse or entrapment accident occurs, the speed of the initial response significantly impacts the survival rate. Therefore, the sequence of actions immediately after an accident is crucial. First, the moment an accident occurs, immediately stop all work and equipment operation. As further collapses may occur, control access to dangerous areas, evacuate all personnel, then quickly identify everyone's location through a head count. These situations shouldn't be handled alone. Immediately report it to a manager or safety officer, letting them control the site. During the site control phase, a perimeter must be established to restrict access, and areas with a risk of secondary collapse require temporary reinforcement. If rescue teams approach without confirming ground stability, even rescuers can be endangered, so a phased approach is essential. It's important to deploy monitors to continuously check for additional deformation or soil movement. If necessary, shoring reinforcement or drainage measures must be implemented first. Then construction can proceed safely. In the rescue phase, the buried person's exact location must be found. Once confirmed, immediately call for rescue and provide protection. Reinforce the area to prevent more soil from entering. After extracting the victim, provide immediate first aid and transport them to a hospital, coordinating with 119. Reporting and site preservation are also crucial procedures. Upon an accident, immediately report to authorities and preserve the scene as much as possible. Document with photos and videos and prohibit moving equipment that could obscure the accident's cause. The situation at the time and response times must also be accurately recorded. After the accident, measures are necessary to prevent secondary incidents. After the rescue, re-inspect the ground and shoring, and immediately reinforce any remaining risky areas. Analyzing the cause of the accident and preparing measures to prevent recurrence is essential. Additionally, conducting worker training again and supplementing the emergency manual are necessary to prevent the same accidents from happening again on site. In this lecture, we looked at the causes and prevention methods of the most fatal accidents on construction sites, collapses and burial incidents. You've surely seen through numerous examples how seemingly minor issues like ground instability, inadequate drainage, or faulty shoring installation can ultimately escalate into major accidents. Because collapse and burial incidents cause extensive damage once they occur, pre-inspection and strict adherence to basic procedures are absolutely paramount. Before starting work, check the ground conditions and drainage situation, and if any signs of danger are seen, report them immediately and stop the work. This simple fundamental is the most powerful safety measure for protecting lives. When both supervisors and workers diligently fulfill their roles, site safety levels improve. I hope the topics we discussed today will be naturally put into practice in your actual work, becoming part of your daily routine. Your small efforts can sufficiently prevent collapse accidents at the site. Thank you.